Hello. Let's talk about solutions in general, and particularly as we talk about aqueous solutions. In general, a solution is a homogeneous mixture of two or more substances. We generally think of solutions as being liquids, but they can also be solids. Bronze is a type of solution, and the air that we breathe is a homogeneous mixture. It's a solution. In that, if it's a homogeneous mixture, it's got a constant composition throughout, no matter what sample that you take from that. The substance is present in the largest amount is referred to as a solvent. And so we're talking about aqueous solutions, and so the solvent's going to be water. The other substances that are present are called solutes. They're present in a lesser amount compared to the solvent. So solute plus solvent gives you the solution. An example of this would be a cup of hot tea. We've taken the tea and we've gotten the different chemicals out of it as we've seeped the tea bag, and the water is a solvent. All the chemicals from the tea are the solutes, along with whatever sweetener that we might have put in there. We can take solutions and classify them as being electrolytes or non-electrolytes. An electrolyte is a substance that dissolves in water to yield a solution that conducts electricity. And so the picture that you see to the right, there's a beaker with a solution in it, a couple of electrodes. You see some copper wires coming off of the light bulb apparatus that's hooked up to some sort of power supply. And so the electrodes aren't connected, they're in the water, and so there has to be something that's communicating between those electrodes, taking the charge back and forth to close the circuit and make the light bulb come on. And so that's what the electrolyte is. It's a substance that when it dissolves in water yields a solution that conducts electricity, as shown by the green circles with a negative charge on the anions, the positive circle there are the cations. And so an electrolyte undergoes dissociation and breaks apart into its constituent ions. And so if we take something like sodium chloride, it's got that three-dimensional crystalline structure, that lattice structure. The water dissolves, breaks it apart, and also that sodium chloride dissociates. And as it breaks apart, it makes these separate ions. And so we got sodium chloride that's a solid, you put it into water, and the sodium ions from the crystalline structure are free to move about in the water, and the chloride ions are free to move about. It dissolves and dissociates. So soluble ionic compounds dissociate completely, and they're known as strong electrolytes. If you dissociate completely, you're a strong electrolyte. More on that a little bit later. Versus weak electrolytes versus non-electrolytes. So if you're an electrolyte, you can be either strong or you can be weak. So if you remember back from the previous slide, we had this light bulb that was very well lit. Now this one's just sort of glowing a little bit. And so there are not as many particles that you see in the solution that have a charge. And so if there are not as many charge carriers between the electrodes, the current can't flow as readily. So that light bulb is going to glow less brightly. And so where do we get weak electrolytes from? They're not from ionic compounds, but actually from molecular compounds, covalent compounds. But some of them will form ions when they dissolve in solution. They only partially dissociate. So strong electrolyte dissociates 100% completely. Weak electrolyte only partially dissociates. And so what sort of compounds do this? Weak acids and bases are molecular compounds that ionize that are weak electrolytes. More on that as we go through this chapter. Non-electrolytes don't conduct electricity. They dissolve in the water. They become hydrated. Their crystal structure breaks apart, but it doesn't break apart to form ions, so that there's no conduction of electricity. So table sugar, sucrose would be an example of this. C12H11O22. Nothing but carbon, hydrogen, and oxygen. It's not going to dissociate. And so here you can see the model, the little water molecules floating around in there, the sugar molecules, but the light's not lit at all. There's no charge carrier in the water at this point. So we've got electrolytes, they're weak and strong. Then we have non-electrolytes. So dissolve versus dissociate. I want to make sure that you understand this difference. That dissolve simply means you're going into solution. That the particles become surrounded by water molecules. So table sugar was an example. It's a covalent or molecular compound, and it only dissolves. Whereas dissociate means to break apart into ions. So sodium chloride, potassium chloride in this particular example, it solubilizes, it dissolves in water, but it also dissociates. It makes those potassium ions and those chloride ions. So we've been talking about strong and weak electrolytes, and we mentioned that weak electrolytes come from weak acids and weak bases. So to be able to differentiate those, you need to learn the strong acids. So here's a table with the 7 strong acids. You need to memorize these. Hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, chloric acid, perchloric acid, and sulfuric acid. There's a little caveat there that just the first hydrogen on that sulfuric acid is strong. You'll need to remember that when Chem 112 comes along. But for now, you need to memorize these 7 strong acids. So weak electrolytes is a compound that produces ions upon dissolving, but exists in solution predominantly as molecules that are not ionized. The light bulb is only partially lit. And so here's an example of a weak acid. This is acetic acid, HC2H3O2. It's the active component in vinegar. It partially dissociates in that one of the hydrogens comes off to make an H+ ion that's solubilized, and the acetate ion, which is C2H3O2-. So acetic acid only partially dissociates. Roughly out of 1,000 molecules of acetic acid, only about 4 of them will dissociate. Whereas if you look at a strong electrolyte, it 100% dissociates. A weak base would be something like ammonia, where ammonia reacts with water, and the water molecule breaks apart, dissociates, if you will, and to produce an OH ion, hydroxide ion, which is what the strong basis becomes in water, and then the ammonia picks up an H+, become the ammonium ion. So weak acids and weak bases are weak electrolytes. Ionic compounds are strong electrolytes, along with the strong acids. We'll talk about the strong bases a little bit later in the chapter. And then you have your non-electrolytes, which are molecular species that don't ionize. So here's a little flow chart to give you a decision tree of how to go about making these decisions of whether something's weak or strong. So is a compound ionic or molecular? If it's ionic, the compound is going to be a strong electrolyte if it dissolves in water. If it's molecular, now you got to ask yourself, is it acid, base, or neither? If it's neither, the compound is a non-electrolyte. No ions are formed in water. If it's a base and it's molecular, the compound is going to be a weak electrolyte, like ammonia. And if it's an acid base, if it's an acid, then you got a question to ask yourself. Is it one of the 7 strong acids? If yes, then it's a strong electrolyte. If the answer is no, then it's a weak electrolyte.